this is Edward. I'm a senior undergrad at UCSB, and I'm applying for a PhD in applied math. Today I'm going to talk about basically mathematics, but also I'm from a life and happiness perspective. So to me, life is a series of problem solving. It doesn't have to be big. For example, you want to sit, there's a problem. You find a chair, you sit down, problem solved. And what's special about problem solving, other than other thing we do in life, is it brings us happiness. We have a problem and try to solve it. There can be two consequences. One, you success, you solve the problem, you feel happy. Second, you found challenge, you can solve the problem, but that means you can learn from it. There's something you don't understand, and if you learn, you feel happy as well. So problem solving is very essential to us, just because, not only because it's useful, but because it brings happiness. So now I'm going to introduce a way, not the only way, but a very effective way of solving problem. So think about this: if we have a potato, arbitrary shape, we throw it in the air, it rotates, we fall down. The motion is really complicated. It's really hard to analyze. So we simplify into physics. We approximate with an elliptical object. However, physics is not flexible enough still. So we translate into mathematics a language, a perspective that is flexible enough that it can generalize. You can create homomorphism, isomorphism. After doing that, you can specialize back to physics, but now you can deal with spherical object as well. And when you go back to the real world, you can throw banana, you can throw orange. And that is the process of solving problem. As an undergrad physics major, we touch all the 5 pieces. But after exploring all the 5 pieces, I found myself particularly interested and good at those 2 steps, translating and generalization. That's why I want to pursue a PhD in mathematics. And now, why am I so passionate about it? Well, maybe I can illustrate with one of my favorite subjects, topology. Topology, let's just give an example with continuity. The first definition we're given is in real analysis with the epsilon and delta thing. It is useful and it is short, not very long. But then after we introduce metric space, distance, we can define it in terms of ball, and we're no longer limited ourselves in a Euclidean space or two-dimensional space. But moreover, if we think about topological space, we can purely define continuity based on openness. And this is very, very pretty, very elegant. And the beauty of it is the reason that I really like mathematics. And lastly, I'll talk about why Quran, why I choose Quran. Of course, Quran is the top score, the ranking, the number, everything is good. But on top of that, this summer I visit Quran in person, and I visit a few professors as well as the admission office. I realized 2 things. One, all the people there I meet, they are very intelligent, but very friendly and humble. Second, as I walk along the hall, I see many doors open. And I think this represents something. This represents that this is a place where intelligent people meet, talk, but with a very open mind and very humble heart. And this is a place I think will maximize my ability, my talent, my passion, and also my happiness. This is a place I want to be in. That's why I want to be in Quran. This is Edward. Thank you for listening.